Now, dear student, let us discuss about the types of chemical vapor deposition process. Dear student, please note that chemical vapor deposition process is a very diverse technique, and on the basis of treating a reactant or a precursor in a reaction chamber, and on the basis of reaction of chemical precursor on a substrate, the chemical vapor deposition process is divided into wide range of different types. So you can basically classify chemical vapor deposition process by operating conditions, that how in chemical vapor deposition process a reactant is operated. You can basically classify on the basis of that the type of chemical vapor deposition process. You can classify on the basis of characteristic of the vapor, physical characteristic of the vapor inside the reaction chamber. You can classify the type of physical chemical vapor deposition process on the basis of heating of substrate. You can classify chemical vapor deposition process on the basis of plasma method inside the reaction chamber, that how the plasma is created in an enhancement form and then form a thin film. You can classify the chemical vapor deposition on the basis of atomic layer deposition and even many more. So, dear student, chemical vapor deposition process is a very diverse type of deposition process, and in this section I will just simply explain in a very shorter fashion about the type of physical vapor deposition, chemical vapor deposition process on the basis of initiating a chemical reaction on the substrate, on the basis of treating a chemical reactant in the reaction chamber. However, if you want to have an in-depth information about the types of chemical vapor deposition processes, you can follow our further lectures. So, on the basis of operating conditions, you can classify chemical vapor deposition process into three main types. First type of chemical vapor deposition process is known as atmospheric pressure chemical vapor deposition process. So basically, this atmospheric chemical vapor deposition system basically operate at atmospheric pressure. You know that atmospheric pressure is around 760 Torr. So you in atmospheric pressure chemical vapor deposition process, you do deposition around 760 Torr. So now if you do a chemical vapor deposition process in atmospheric pressure, then there is a lot of possibility of impurities in a deposited thin film, because at atmospheric pressure the mean free path between the molecule of the precursor gas become very short and the molecule collide. As a result, the chemical reaction even take place inside the reaction chamber before reaching onto the surface of the substrate. So though in some conditions atmospheric pressure chemical vapor deposition process is used. Another type of chemical vapor deposition process based on operating condition is known as low pressure chemical vapor deposition process. So basically the low pressure CVD is done at sub-atmospheric pressure. Reduced pressures tend to reduce the unwanted gas phase reaction and improve the uniformity across the vapor. across the wafer or substrate. So basically, a pressure is basically decreased in low pressure CVD process. It depends on the device and its requirement, that what kind of instrument CVD machine you are using. So you can basically reduce the pressure according to the system. Okay, and by reducing the pressure, they basically increase the unwanted, they basically decrease the unwanted gas reaction inside the reaction chamber, and that's the reason that you get relatively better and uniform thin film as compared to the atmospheric pressure CVD process. Third type of CVD process based on operating condition is known as ultra high vacuum CVD process. Now this type of CVD process or CVD technique is very important in terms of sophistication. This is basically ultra high vacuum CVD is basically a CVD technique, a core CVD technique of microelectronic industry. Basically with this technique you can get highly pure, even highly pure ultra thin film. Why you get ultra highly pure thin film? Basically with ultra high vacuum CVD process, usually the pressure is usually taken up to 10 raised to power minus 8 torr. So this is very ultra high pressure. Okay, so CVD at very low pressure, typically below 10 raised to power minus 6 Pascal or 10 raised to power minus 8 torr. This ultra high vacuum basically result into a decrease in a collision of the gas molecule of the reactant or precursor inside the reaction chamber, and on the basis of that you can easily transport a precursor material in a form of gas on the surface of the substrate where chemical reaction take place, and you can get a very uniform thin film with very rare impurities. So that's the reason this technique, ultra high vacuum CVD, is used in microelectronic industry. Another type of CVD process is known as subatmospheric CVD process. Basically in subatmospheric CVD, a small subatmospheric pressure is used in the reaction chamber. So this class of subatmospheric pressure CVD is also a very important type of CVD process, and it is also common in thin film deposition by considering the physical condition of processing. Now, dear student, CVD process may be classified on the basis of the physical characteristic of vapor. Basically, on the basis of physical characteristic of precursor vapors, CVD is also classified. There are two main types of CVD processes which are based on physical characteristic of vapor of the precursor gas. First type of CVD is known as aerosol assisted CVD process. In aerosol assisted process, the precursor are transported to the substrate by a means of liquid aerosol, which can be generated ultrasonically. So in case if you want to deposit a non-volatile precursors on substrate, in such conditions the aerosol assisted CVD processes are very important. So if I conclude, aerosol assisted process basically transport precursor to the substrate surface by a mean of liquid aerosol. Okay, liquid aerosol take away the precursor, which may be in the form of gas, usually in the form of gas, onto the surface of the substrate, and their chemical reaction take place. So this aerosol assisted technique is mostly suitable for taking the for deposition of non-volatile precursors. Now, another interesting type of chemical vapor deposition process based on characteristic of vapor is known as direct liquid injection chemical vapor deposition. This is very important type of CVD process. It is a modern type of CVD process. Lot of materials like various phase materials like bismuth, titanates, ferrites, etc. thin films, they are basically nowadays they are produced in a very controlled fashion by using direct liquid injection chemical vapor deposition process. Basically, in this process, a precursor is used in a form of a liquid and is then transported through an injector in a form of gas on the surface of substrate, and then at the end you get a thin film on the surface of substrate. So basically, direct liquid injection chemical vapor deposition process have an injector near the reaction chamber, basically, which inject the precursor material in a controlled fashion onto the surface of the substrate. So in this way, with this advanced technique, you can get high quality, well textured oriented thin films. In direct liquid injection chemical vapor deposition process, the precursor are in liquid form. So a liquid or a solid is dissolved in a convenient solvent. Okay, usually toluene is used as a solvent, and in which the liquid in the solvent toluene, the liquid or a solid precursor material is dissolved. Then liquid solution are injected in vaporization chamber toward the injector. The precursor vapor are then transported to the substrate as a classical CVD. Okay, basically liquid solution which is present in a stainless steel precursor holder is vaporized, is transported into a vaporizer, and then vaporizer basically, when the liquid precursor in the form of liquid is just reached into a vaporizer, the vaporizer basically vaporize the liquid liquid precursor, and then it's just transport that precursor in the form of gas into an injector, and injector basically introduce the gaseous precursor onto a substrate in a controlled fashion, and on this way basically you deposit a thin film on the surface of substrate. So basically, students, these are the two types of the chemical vapor deposition technique based on characteristic of vapor. First type of chemical vapor deposition technique is known as aerosol assisted chemical vapor deposition process. In aerosol assisted CVD, you transport a precursor by a mean of liquid aerosol or gas aerosol onto the surface of the substrate. Whereas in direct liquid injection chemical vapor deposition process, a precursor usually is present in a form of a liquid, is transported into a vaporizer, which basically convert a liquid precursor into a gaseous phase, and then it is transported into injector, which control the injection which control the flow of the precursor gas in the form of injection or in the form of pulse. And on the basis of that, on the basis of injection, the thin film is basically deposited on the surface of the substrate. Different CVD process may be based on the heating of a substrate. Usually, the CVD process based on the heating of substrate is divided into two types. First type of CVD process is known as hot wall CVD process, and second type of CVD process is known as cold wall CVD process. Dear student, in hot wall CVD process, the chamber is heated by external power source, and the substrate is heated by radiation from the heating chamber wall. So the student, with hot wall CVD process, both the reaction chamber may be heated externally. Usually the different types of IR lamps are used to heat the hot wall CVD kind of CVD instrument, CVD reactor, and the substrate is also heated. So both the reaction chamber and substrate used in hot wall CVD are heated, and due to a variation of heat, basically a deposition of thin film takes place. Now student, please note that the hot wall CVD is a variable technique, a temperature gradient technique, and it may be used to deposit a single crystalline kind of thin films or single crystalline nanoparticles and nanorods or nanowires. Another type of CVD process based on heating substrate is known as cold wall CVD process. So cold wall CVD process is a process in which only substrate is directly heated either by induction or by passing through a substrate itself, or a heat in a contact with a substrate, and whereas the chamber walls are present in a room temperature. So in a cold wall CVD processes, the reaction chamber is usually present at room temperature, whereas the substrate is heated by different means, like by introducing inductors with the substrate, or etc. Now this type of CVD is also important. Like if you want to have a better adhesion on the surface of substrate, you need a slightly heat of a substrate, which basically causes a better diffusion of a chemical reaction of the reactant on the surface of substrate. So both the cold wall and hot wall CVD have their importance. So if I conclude, the CVD may be classified on the basis of substrate heating. The first type of CVD is known as hot wall CVD, and in hot wall CVD the reaction chamber and as well as the substrate are heated. Whereas the second type of CVD based on heating substrate is known as cold wall CVD, and cold wall CVD have just heating substrate, whereas the reaction chamber is present at room temperature. Now, this is very important class or very important type of CVD. CVD may be characterized based on plasma. So you can say such type of CVD as plasma based chemical vapor deposition. Based on plasma, dear student, CVD is divided into main 4 types. First type of CVD based on plasma is known as plasma enhanced chemical vapor deposition. So basically, in plasma enhanced chemical vapor deposition, the plasma enhancement is done inside the reaction chamber of the CVD apparatus before the precursor in the form of gas is deposited on the surface of the substrate. So basically, the precursor material, which is in a form of a gaseous phase, is converted into a plasma in plasma enhanced chemical vapor deposition system, and then the chemical reaction of the plasma is initiated on the surface of the substrate, and at the end of the day you get a thin film based on plasma enhanced chemical vapor deposition process. So basically, plasma enhanced chemical vapor deposition process utilize the plasma to enhance the chemical reaction on the chemical reaction of the precursor on the surface of substrate. PECVD processing allow the deposition at lower temperature, which is often critical in manufacturing the semiconductors. So PECVD is a core technique of semiconductor industry where you need a low temperature deposition, where you need a deposition with less defects. The lower temperature allow the deposition of organic coating such as plasma polymer that have been used for nanoparticle surface functionalization. So basically, organic coating is very difficult at higher temperatures. So PECVD, it's operate at a lower temperature. So this will basically avoid the damage of the organic molecules, and that's the reason you can basically easily deposit different types of organic coatings such as polymers by using PECVD process, which they are then used for surface functionalization. Second type of CVD process based on plasma is known as microwave plasma assisted CVD. So microwave plasma assisted CVD operate at microwaves. Another type of CVD is known as remote plasma enhanced CVD. The remote plasma CVD is a same type of plasma enhanced chemical vapor deposition technique, but the difference between the remote plasma CVD and plasma enhanced CVD is that in remote plasma CVD, wafer or a substrate is not directly in the plasma discharge region. So basically, the substrate on which you are going to deposit a film is not directly present in a discharge region. So removing the substrate from the plasma region allow the processing temperature down to a room temperature. So this means that with remote plasma enhanced chemical vapor deposition process, you can even deposit thin film at room temperature. Another type of CVD process based on plasma is known as low energy plasma enhanced CVD process. Basically, in low energy plasma enhanced CVD process, a CVD is implied when you need a high density, low energy in order to deposit epitaxial deposition of semiconductor material at higher rate and low temperature. So basically, low energy plasma enhanced CVD process used if you need a dense coating at a low temperature. Now let's discuss about the common CVD techniques which are basically used in lab or which you are using in laboratories. The one of the most commonly technique used in a lab is known as atomic layer CVD. This is very interesting type of CVD. So in case if you want to deposit a layer by layer deposition on the surface of substrate, you can use atomic layer chemical vapor deposition. So initially, as you know that in CVD you have different types of precursors present. So you can basically deposit different types of precursor on the surface of substrate at different time. So atomic layer CVD technique, basically a type of CVD technique, is very helpful if you want to do a layer by layer coating. Another common type of CVD which is used in lab is known as combustion chemical vapor deposition. Combustion chemical vapor deposition is also known as a flame pyrolysis technique. So this technique is based on flame. Okay, so combustion where chemical vapor deposition is known as flame pyrolysis is an open atmosphere flame based technique for depositing high quality thin films and nanomaterials. So in combustion CVD technique, basically you combust the precursor material, and that combusting material in a form of gaseous molecule is just transported and deposited as thin film by doing a chemical reaction on the surface of substrate. One of the common technique used in a lab, CVD technique used in a lab, is known as hot filament CVD. The hot filament CVD is also known as catalytic CVD, or more commonly initiated CVD. This process uses a hot filament to decompose the source gas. So basically, in hot filament CVD, the hot filament are adjusted and near the reaction, near the substrate of the reaction chamber, and the hot filament basically they decompose the source gas which is transported onto the surface of substrate. The filament temperature and the substrate temperature thus are independently controlled. Allow the colder temperature for better absorption rate at the substrate and higher temperature necessary for decomposition of precursor on free radicals at filament. Okay, so hot filament CVD have a filament which is quite hot and which is placed near the substrate. The temperature of substrate and the filament is different. The filament basically heat up the precursor material which is in the form of gas, is present inside the reaction chamber, and then they basically do a chemical reaction and they convert decomposed material into a thin film. So another type of chemical vapor deposition process is known as hybrid physical and chemical vapor deposition process. As it is clear from name, hybrid physical and chemical vapor deposition process is a combination of physical and as well as chemical vapor deposition process. Hybrid physical and chemical deposition process involve both chemical decomposition of precursor and vaporization of solid source. So both are done in the same system. Initially, the precursor is vaporized and then it is chemically decomposed by CVD setup. One of the most common technique used in CVD system, or one of the main important type of the CVD, is known as metal organic chemical vapor deposition. It is quite clear from the name that metal organic CVD have metal organic precursors. Okay, they use a metal organic precursor as a precursor material, which are usually present in a form of liquid and maybe solid, but they are usually in form of liquid in a solvent like toluene, and they are then basically evaporated and transported onto the surface of the substrate. So MOCVD is very important type of CVD. It is very common in research lab. I will explain this technique in next of my lectures, and please follow those because MOCVD is very important and it is very useful for researchers. So the student, another type of common CVD technique is known as rapid thermal CVD. This CVD process uses the heating lamp or other methods for rapidly heating the vapor substrate. Heating only the substrate rather than the gas or chamber wall helps to reduce unwanted gas phase reaction that can lead to a particle formation. Now this rapid CVD is very important. If you want, in general, you get a uniform thin film, but if you want to have a variation of chemical reaction and variation of composition on the surface of substrate, you can use the rapid thermal CVD processing or rapid thermal type of CVD. You vary a heat at a different time during a chemical reaction, you can get a different variation of composition of thin film on the surface of substrate. One of the most common technique used in chemical vapor deposition process is known as vapor phase epitaxy. Basically, vapor phase epitaxy, as I previously discussed, that the precursor molecule is converted into a vapor phase, and then a vapor phase is then deposited on the surface of the substrate as an epitaxial thin film. So this is also very important type of chemical vapor deposition process. One of the most common technique, I have discussed the combustion CVD, so I don't need to discuss it here. Now this is also one of the most important type of chemical vapor deposition process, and it is known as photo initiated chemical vapor deposition process. So basically UV light is used in chemical vapor deposition systems to initiate a chemical reaction on a surface of the substrate. It is similar to plasma processing, given that plasma are strongly emitters of UV radiations. Under a certain condition, photo-initiated chemical vapor deposition can be operated at or near the atmospheric pressure. So you can basically operate this type of CVD process at near atmospheric pressure, but still there is a possibility of a kind of impurities. But the interesting fact to notice here is that you can basically initiate a chemical reaction on the surface of substrate by using UV light in photo-initiated chemical vapor deposition process. Another common type of chemical vapor deposition process is known as laser chemical vapor deposition process. This CVD process uses a laser to heat a spot or a line on a substrate, and it is commonly used in a semiconducting industry, in semiconducting applications. In MEM and in other fibers production, the laser are used rapidly to break down the precursor gas. Process temperature can be exceeded up to 2000 degrees centigrade. So basically laser is used in laser chemical vapor deposition process to break the chemical precursor or chemical precursor gas, and then they react to form a thin film. This technique, laser chemical vapor deposition process, is a core technique of MEM and fiber industry.